Okay, I've got a request via Piazza to talk a little bit about the member variable derived class a bit. I'm happy to do that. Before I do that, are there any other questions you'd like to ask? Yes?
What's the final going to be like for, like, what's going to happen? Do we not have any projects?
It will not be a traditional written final.
So do we still have to come to the class?
Yes, you do have to come to the class.
Okay. But we're just going to work on
Hmm?
Like we're just going to work on a project or something? Or?
Yeah, I'll figure something out.
Okay.
You bring you bring the cake and I'll bring the balloons.
Okay, nice. I'm down with that.
And I'll fill each balloon with a mystery gas and we'll see whether you get a squeaky voice or you pass out. Other questions? All right, then I will dive into the derived member variable class. Step 11. What is this? That's not it. Okay, so step 11 is very much analogous to the variable production. And the variable production comes about where in GPL I say int x, you give the value, so that right there and for us to understand the function of variables in this whole parsing strategy, you need to understand stuff like this here. And this here, I think we're comfortable with that, ends up being, we come across a literal number like that, and we end up creating a constant integer object. But we don't know, further on down the chain, I eventually end up with a plus object, and the plus object has something on the left-hand side and something on the right-hand side. And if we crack open the plus class, the left-hand side and the right-hand side are expression pointers. So for us to look at this code, you know and I know that 10 is a constant integer. The plus class doesn't have the slightest idea what it is. All it knows is it's some kind of expression. And the expression constitutes the base class for the majority of the classes we have in this project. All the operators, the constant integer, the constant double, the variable, everything is some sort of directly or indirectly derived from expression. And our motivation for doing that is it lets us take advantage of polymorphism, which is basically asking something to do, making a request that's identical, and depending on the underlying object, you get different behavior. And the key thing that in all this stuff that we want to ask these various objects to do is we want to ask them to evaluate. Now, regardless of what it is, If it's a variable, or it's a plus, or it's a constant integer, if we ask it to evaluate, we are 100% guaranteed to end up with a constant integer. Once we have that not constant integer, excuse me, constant object. That object may be an integer or a double or a string. Or now, yeah, let's stick with that. So, painting it with that huge brush, the reason to have a variable class is that we need some way in this example to capture that x, pass it around, make it part of this whole expression tree, and at some point in time we want to ask it to evaluate, and when we ask it to evaluate, it'll do whatever you need to do when you ask a variable to evaluate. We know it's going to give us a constant object ultimately if I ask it to evaluate. So in order to succeed with with pulling this off and writing code, we write a variable class, and we have to override those functions that are pure virtual in the base class. So if I look at, I've got to go to a different pane here. Okay, here's my expression class. These two functions right here are pure virtual. I am not allowed to write, well, let me step back. I can write any class I want that's derived off expression. If I want to be able to create an object from that class, I have to write a version of these two functions. A couple of you have gotten errors at one time or another where it seems to compile everything fine, and then the linker complains about a vtable. That is a symptom whose cause is that you did not write one of these functions. Actually, that isn't true because it would you wouldn't get past the compiler with that. Yeah, I'll go with that. I'll go with that. You didn't create an object. All right. So if you don't write these functions, you create a derived class. You do not write these functions. You cannot create an object. So I can create a variable class that's derived off of expression, but I cannot create a variable object if I have not written these two functions. The first one is type, and there's a certain obviousness of intuition. Where's my, yeah, that's right. We can stare at this code and we know the type of x is an integer because by golly we created it as an integer up on line 1. So there's some code we have to write, and we know that when we call the type function on a variable object, it will return integer. Next is we have to write evaluate for this variable. What do we do when we evaluate an integer? What do we need to know? Or excuse me, when we evaluate a variable, is we need to know what its entry is in the symbol table. All right, the symbol is what ties the identifier x with the actual underlying data. And so a variable is not a symbol. A variable is a class that we have created as a construct to represent some portion of GPL, just as plus is a class that we developed to represent some construct in GPL. So this variable class must have as part of its data a symbol, a pointer to a symbol. And in fact, let's go look at my code. Variable, that's not here, I've got it in its own. All right. There's a variable class. What do I want to hone in on here? These two functions. I have to write those two functions, or I will not be able to create variable objects. Here, I've got a pointer to a symbol. And now our ability to evaluate becomes becomes possible, I guess we should say, because when someone takes my variable object and says evaluate, what I go is I go to this data here and I say symbol, give me your value, and it gives me whatever it was, 5 back, and then I create a constant integer object wrapped around that 5, and voila, I've met the requirements of evaluate. Note that the variable class here is, for lack of a better term, overloaded, not only to handle discrete variables, but to handle an element of an array. Not an array itself, but an element of an array. So I could say int arr 30, and then somewhere down here I could create an integer z is equal to arr sub 23 plus 10. Okay. On line 8 there, arr sub 23 also is I'm going to have to write code when I come across that to create another variable object. So the variable object handles both individual variables like on line 4 and elements of array like on line 28. This 23 that I put in here can actually be arbitrarily complex. I can say 23 plus 4 plus x. Or hell, let me mix it up. Let me make it multiplication. Right? That can be any sort of arithmetic expression. Since it can be an arbitrarily complex expression in there, if I come back here to my variable class, this is what I have a pointer to an expression. So whatever's in the square braces becomes an expression that I store as part of my variable. If I only have a discrete variable like x in the example I've been looking at, then line 20 is null, or a null pointer. I don't need it. I don't use it. It's not an array element. And I just have a pointer to the symbol. If it is an array element, I have a pointer to that symbol, which, if you recall, you store arrays of items as symbols as well. So what did I have for my code? So on line 2, that generates a single entry in our symbol table, which will tie the identifier ARR with an array of 30 integers. So if this is null, it's a discrete value. If it's not null, we need to evaluate that and get it as an integer to find out which one of those 30 integers I need to build a constant object out of and return as part of evaluate. Okay? So using that entire speech as preamble, let's look at member variable. So member variables, I create a rectangle, R, let me call it rect. And now I can do things like int w equals things like that. So I should say this would be rule 1 of the variable production. This would trigger rule 2 of variable production. This triggers rule 3 of the variable production. And then finally, not only can we create a rectangle, but we can create an array of 30 rectangles. And if we create an array of 30 rectangles, then I can, let me copy and paste. make that R. No, have I used R? Let me see. I'm running out of letters of the alphabet. T. Or let me. So rules 1 and 2, you end up creating a variable object. Rules 3 and 4, you end up creating a member variable object. So member variable is a class you have to write. The one thing that you'll notice that I did with my code to change it is that I changed it from private to protected because, and if you're a little bit hazy on the distinction between the two, if I make it protected, then classes, any code I write in member functions of classes derived from variable also have access to this data. And that's what I want. I want member variable to be able to access those two pieces of information. So the question to ask is, are those two pieces of information enough? Is it enough to have a pointer to a symbol and some sort of expression in case it's an array element? And let's start with this version here. So to have a pointer to the symbol, what symbol am I pointing? Give me a little bit of information, a bit of feedback on what symbol I'm pointing to in the symbol table. Which symbol is in the, tell me what kind of symbol is sitting in the symbol table for me to do anything useful with this. Say it again? Yes, an array of 30 rectangles, in fact. There is one entry in the symbol table, one symbol that is. The identifier is RARR, and the bit of data in there is an array of 30 rectangles. So I've got a pointer to an array of 30 rectangles. It'll be easy enough for me to get the 24th one. Remember, counting starts at 0, so that's a 24th rectangle, not the 23rd rectangle. And I've got an expression pointer, so this 23 or whatever the arbitrarily complex expression is in the square braces, I'm able to store that information. But what am I missing? Let me ask a different question. And this is actually a more complex version of a question I ask my 111 students all the time. What is the type of the thing I have highlighted?
Integer?
An integer, exactly, it's an integer. Okay. What's in the symbol table are 30 rectangles. But the type of this expression is an integer. So we got a bit of a gap there. And how are we getting from one to the other? The amount of information I have in the variable class is insufficient. It gets me to the entry in the symbol table. I can also get at the nth item if it's an array. But I also need to know, in my example here that's highlighted, I need to know that the member variable I'm interested in is x. Because a rectangle has 24 member variables, and I need to know which one. I need to know if it's x or y or radius or red, and then depending on what it is, that'll be an integer or a string or a double. So my member variable class inherits from the variable class, and it gets all these goodies, but I'm going to need one more piece of data that doesn't exist in variable. I need some sort of string that stores the name of the data member. In this case, x. And then I'm going to have to write an evaluate function and a type function. We'll look at those in just a moment. Let me focus for a little bit on the constructors, because if you haven't done a lot with inheritance, the constructors could be a bit confusing. Let's look at the constructors for variable. If I have a discrete variable like x, where I just say x plus 5, then all I need when I create a variable object is I have to have found the symbol in the symbol table and I pass the pointer in. The other version is if I have the array and I'm looking for a particular item, I need still the pointer to that symbol, plus I need a pointer to the expression that's inside the square braces. Okay. I still need all that information for member variables, so you'll notice these constructors also require a pointer to a symbol, and in the second case, a pointer to the expression that goes inside the square braces. But I am now adding an additional piece of information here, which is a string representing the name of the member variable for that game object. And it's the same for both of these. So let's write the constructor for one. Let me write the constructor for this bottom one. Yeah, that's fine. So I say member variable, colon, member variable. I have all this stuff. It's a bit messy. I don't have enough real estate on my screen. I'm actually going to hit enter. Note that this would be somewhere inside of some CPP file, obviously not crammed in here in the header file. I have a body to the constructor, but I have an initialization list. And when you're dealing with derived classes, I guess this was, let me see, I guess we did some of this, so that isn't that big of a mystery. I need to list all of my private data members, in this case, data member name. And the other thing I have to list is the base class. I have to initialize the base portion of my class. I'm inheriting from variable, so I put the word variable there. Now it's just a matter of filling in what goes in the parentheses. Data member name is being initialized with, looks like data member namer. I'm going to just abbreviate that, data member name. Oh, there we go, I got my real estate back. So that is being initialized with data member name, and then the base class has to be one of these two constructors. It's definitely going to be the second constructor, which is a symbol pointer and an expression pointer. So that'll be sim index expression. There you go, constructor written. Same process for the other constructor. You're going to have to write this type function. I have a symbol. I can call member functions on that symbol. Where did this come from? This is protected data that I can access directly in derived classes. They're on line 19. I can call member functions on it. Let's say for the sake of argument that we already know it's a rectangle. Actually, let me take a step back. Let's get rid of the member variable stuff. What if I know that my symbol stores a double? What member function in the symbol class do I call to get the actual data? We can look at the symbol class. Symbol.h. Right here. On any symbol, I can call as double, and it'll give me its data as a double. Oops, now I'm getting confused here. Where am I? So if it was a double, I could do that and get it as a double. But it isn't a double. Let's say we know it's a rectangle. Well, there you go. In the upper left-hand pane, line 62, you have already written, based on previous steps in this project, an as rectangle. It's going to give you a rectangle pointer, so you just create a rectangle pointer. game, create some game object pointer. But I actually don't know that it's a rectangle. It may not be a rectangle. Maybe a circle or a text box or a triangle or a pix map. So I actually need to do a switch. I need to, in order to switch, in this particular instance, I would have a case where it's rectangle. This is not correct, and we'll get to that in just a moment. But line 30, what am I switching on? How do I figure out what kind of thing I'm dealing with here with this symbol? Yeah, we wrote a function for symbol, the symbol class called getType, and it should, in this case, return a rectangle pointer, or excuse me, as it'll return a GPL type rectangle. So let me get a bit closer. All right, that gets a bit better. I have some problems, which is the scoping of this GOP variable. And also it has different types. So in this situation, I take advantage of inheritance and the ability to store the address of a derived type in a pointer of a base type. So rectangle, triangle, and the rest of them are all derived from game objects. So what I'll do before I enter my switch, I'll say game object pointer, GOP, and I'm going to initialize it to null pointer with the intent of I ultimately need to return something here. Return the type. So maybe I'm even going further than I need to go. Maybe I don't actually need this. So how do you get... I'm going to actually save this code because I'm a saver. I'm going to paste it down here. So maybe I'm taking a bit more effort than I need to in this case. I know it's a rectangle, but we're looking at the example here on like either maybe line 20 in the bottom left-hand pane here, where I need to ultimately come up and return integer. So I can do this switch and know that I have a rectangle, but how do I know that x is an integer in a rectangle? We come to the Readme. We have these functions here. Drop the const. That shouldn't be there. Doesn't matter. Doesn't hurt understanding, I don't think. Let me do a copy paste. Zoom in. I have to provide a string. That takes me to this, the data member name. All I have to do is provide the data member name, and it'll tell me what kind of thing that data member is. Data member name. So I don't need that after all. So that'll return int or integer or whatever the GPL type enumeration is. There we go. The compiler complains if you don't capture every possible branch, so it's always good to have a default case here. And what I would do in the default case is I might do something like CR no valid type. This is code that I never intend on reaching, but I put it in here because I will reach it if I have a bug. Something like that, and then I put an assert false. Assert false is a guarantee that the program stops dead in its tracks right there. So I'll get that error message and then stop. So that's all there is to type. What about evaluate? All evaluate functions return a constant pointer. This is member variable : evaluate. Now let me go ahead and go with this. I want to throw this code in here. So the first step to being able to evaluate, remember we need to get what x is, right? That's what we need. We need to get what x is. X is not in the symbol table because the way these classes were designed, x is a member of rectangle or game objects in general. So I need to grab the game object and then interrogate the game object and ask it, what's inside your x? And that's what I want to build a constant object out of. So I get the type here. Or I don't want to say get the type. I get the object here. Have a branch to get the game object if it's a member of an array. After that, I'm guaranteed that GOP is pointing to a game object. Now I need to switch on the type of the member variable. All game objects have member functions to be able to get the values of member data. Right here. Get member variable. And if it's an integer, I provide an integer. These are not addresses. These are passed in by reference. So what happens is I pass in an integer variable or a double variable, and it will set them to whatever that game object's value is for that particular data member. Our data member name, in this case, is X. And away you go. yeah, that's right. So what is the type of the member variable? How do I figure that out? How do I figure out whether I'm dealing, remember all my private data is in the member variable class. Where do I have it? I've got it down below. Here's my class declaration in the .h. All I've got is this. How do I determine its type? And the answer is, 10 minutes ago we wrote a function to get its type. Right here. Just call that function. So you can go ahead and just put inside the switch statement. There it is. I'll comment that out. Switch type. Or you can be explicit about it. You can say this type. And that'll come back with the type of that member variable. So let me see, what can I do for you here? That's line 74, we'll say. Lines 28 through 74. Lines 20. There we go. So all that's in today's class notes. Go over steps 1 through 6 in class. All right, let's do a whirlwind of 1 through 6. You'll forgive me if I don't go in quite as much detail with that. Add support for the following game object types to class symbol. If I go to project 3, look at symbol.h. Right now our symbol class handles 3 types. Integer double string. We have to add 5 more types to it. Rectangle, triangle, text box, circle, pix map, and Mobius tube or something like that. Whatever the 5th one is. So this is necessary, but unfortunately it's extremely tedious. Because for each of those, you have to write 2 constructors for each. Note that I have 2 constructors for double. I have this one here, and I have this one here. You're going to have to write 2 constructors for rectangle, which to a certain extent is search and replace. But you're going to have to do it for the other 4 as well. So that's 2, 4, 6, 8, 10 functions you have to write. You have to write as functions for each, and this really becomes a headache. So just as you have as int, as double, as string, write 5 more, as rectangle, as triangle, as circle. And let me make a point here that what is returned are pointers. A pointer to a rectangle or a pointer to a circle. Don't return actual objects. All this stuff propagates. In order to store the data in the symbol, if we look at the private data, here's the key piece of private data. That is a type that can handle anything. This value can be a pointer to a double, or a pointer to an integer, or a pointer to a rectangle, or a pointer to an array of rectangles. In order to facilitate that, we create this type, which is a union of all those different types. So you're going to have to add the 5 types here. And the 5 little constructors here. Also, let me look at symbol.h, or excuse me, symbol.cpp. Not only do you have to add those functions, but you have to come back and modify existing functions. So like this destructor needs to be modified. And the other one that needs to be modified then, I guess, is said in number 2 here. You have to do the operator Chevron. Note that there's already code inside of each of the 5 classes for game objects that already have one of these Chevron insertion operators. Printing out a game object is as straightforward as printing out a string. So it means almost, but not quite. Let me find that operator. Here's where I print out a string. So I could kind of go 3yy, paste, call that rectangle. This becomes, oh, these are arrays. Let me go to the simpler one that is an array. Yeah, right. 3yy, paste, change that to rectangle, change string pointer to rectangle pointer, and that does the job. You're going to find that it fails on the standard out because I've got a set of double quotes in here that I had for the string, which you don't have for game objects. So I'd get rid of the double quotes that I was printing in there. Also, I did this kind of odd. I built a string here. So this would be, and if I look at the string version, GPL type to string would actually have the result of this function call is string plus a space plus the symbol name str string str equals. If you look at the output for game objects, there is no equals. So I would have to change this up as well. And I've got weird assignment. I was modifying code, and so I left some old code in there. I guess what I would do if I was to make this work for rectangle, I'd just paste this down here. I'd say OS, Chevron, I have that, I have that. I'd get rid of the equal sign. And then I'd print out the symbol, the rectangle, and then the rectangle insertion operator handles the rest of it. So that's not stuff you have to have memorized to be sure to do it, because if you don't do it, you'll just look at the difference in output and go, aha, I'm putting an equal sign there, and there is no equal sign in the expected output. So you just go and remove it. That's, where are we up to? That's 2, 3. Go back to symbol. Same thing. Just as you did for the 5 game objects, you have to do for an animation block pointer, so go ahead and do that. Oh, this is the one. Actually, worse, far worse. So symbol was a bit tedious. This one here is no fun at all. Not because it's hard, because it's a huge amount of copy and paste and making copy and paste errors. If you can copy and paste this stuff and get it to work in one compilation, you're a better person than me. So this is adding 6 additional classes to constant. We have integer, double, and string constants. Now you have to add 6 more. That means it isn't as simple as adding the 5 game object classes, because you have to go back and modify the existing classes. Meaning integer constant used to only be these 3 as functions. You have to go back into integer constant and add all of these. So it's tedious. It's very tedious. And here it's showing you an example of what that looks like. Once you do it for this, it's pretty understandable to do it for the rest of the game object classes. Variable evaluate. From project 3, there's my variable evaluate. When you ask a variable to evaluate, it'd just be one of those 3. Now you got a bunch of game objects you got to throw in there. So that's what that's saying. You got to go in and add more cases to those switch statements. All right. So number 6 here, this is all preamble. I actually rephrased this. I haven't pushed the update yet, but I say something like, pretty soon, in a number a little bit further down, you're going to have to write the actions for object declaration. Don't write the actions for object declaration here. It's just giving you a little information. So in order, when you do it down there, it's basically explain, explain, explain. You're going to have to deal with these here. That's what all the explanation is saying. You're going to have to deal with these parameters. So you're going to have to write the structure. Also that I modified in the write-up, I haven't pushed yet. This says add this structure declaration to parser.h. That's pretty easy to do. However, it has to be above the pound include statement for gpl.tab.h. gpl.tab.h is generated when you run Bison, meaning it's generated from whatever's inside of gpl.y, and that generated header file uses this parameter structure. So you have to define this parameter structure prior to including that header file. Otherwise you get undeclared identifiers or something like that, I don't recall. And that's it. That's 1 through 6. Consider that done. I'm going to remove that.
Talk about what could go wrong with number 12 a little bit.
What can go wrong with number 12? Sure. So here's my project 3. Let me look at expression.cpp plus so what do I do with addition? I try to create an integer constant, assuming that my left-hand side and right-hand side expressions are integers. If one of them is unable to be an integer, it's going to throw, and I fall into here, so I go, okay, well, let's assume they're doubles, and then I evaluate them both as doubles, but it's possible that one of them could be a string, so that would throw an exception. So I come here, and now I'm assured, no worries, I'll go ahead and assume these are strings, and do the evaluate and add them together. However, in our brave new world, if I come back up to some sample code here, what if one of these, what if the left-hand side is a rectangle? And then I say a string, that's going to throw an exception. And so I have a problem there. Now, let me see. I'm thinking this through out loud. Is that going to be a problem? Because if you're doing your type checking, the type checking should be happening in that template function, so maybe you won't fall into this and that wouldn't be a problem. That's a good, let me reread this. What did I say? I'm going to
I think the expressions work fine. The problem is like assignments.
yeah, so I think line 9 looks like my number 12, item 12 is moot because all of your type checking should occur in gpl.y, so you'll never use these incorrectly. So, number 12 is a freebie. Don't do anything and you've solved 12.
But you have to do some extra checking in the assignment.
Well, there wouldn't, you mean in the option?
So like, I was just trying to test it and have like string x equals z, which is a rectangle.
Yes. That is the optional initializer. So that's in variable declaration, right? Variable declaration has this type, TID, and then this is optional initializer. And so you do have to make sure your optional initializer is a string and not anything else. Y'all can keep it down before trying to sleep in here. All right. What else? Y'all are going to kill me on Piazza tomorrow night, aren't you? All right. There's no way around it. Well, I will then pause the recording and do my best to support you from afar. All right. Okay.